Good morning, everybody. I'd like to welcome to the platform Queensland Hydro Project Director for the Borumba Pumped Hydro Project, Lee McKenzie. Queensland Hydro is a publicly owned entity established by the Queensland Government to design, deliver, operate and maintain long-term duration pumped hydro energy storage assets. With over 18 years' experience, Lee is a contemporary leader here and overseas with qualifications in both civil engineering and an MBA. Lee brings a unique blend of technical and managerial experience in delivery of large-scale road, bridge, rail and water infrastructure projects. Please welcome Lee McKenzie.
Thank you, Nicola. Can you see that now?
I can see your presentation, Lee.
Yep, fantastic. Thank you very much. So welcome, everyone. I'd like to acknowledge the Kabi Kabi people on the land in which I'm presenting today in Maroochydore. I'd also like to acknowledge the other land where our other project, the Pioneer Burdekin project, resides, which is the Widdy and the Yui and Widdy peoples up in Mackay. I pay my respects to the elders past, present and emerging and their ongoing connection to the country. So as a bit of background to the Queensland Hydro, the Energy and Jobs Plan was released in September 2022, and the plan shows the need for 25,000 megawatts or 25,000 gigawatts of large-scale wind and solar generation, as well as the minimum of 6,000 megawatts of long-duration pumped hydro. Along with the announcement of the Queensland Energy and Jobs Plan, there's also the announcement of the two Queensland Hydro proposed projects, the Borumba Pumped Hydro project, located west of the Sunshine Coast near Imbil, and the Pioneer Burdekin project located north in the Mackay area. So, as Nicola mentioned, Queensland Hydro was established in September 2022, along with the Queensland Energy and Jobs Plan, and that's to build, own, operate and maintain Queensland's pumped hydro facilities. Also announced was our two projects, as you can see on the map here. So the Pioneer Burdekin in Mackay and the Borumba Pumped Hydro near Imbil, near Brisbane. So the Borumba Pumped Hydro project was provided with the final investment decision in July this year, with the Queensland Government providing $6 billion in equity, and Queensland Hydro will fund the remainder of that $14.2 billion project. So just to put it in a little bit of perspective, so people always talk about the need for batteries, and definitely batteries are a part of the solution for the future. So comparing this to pumped hydro, because people always often ask why pumped hydro and why not batteries. So this provides some scale to it. So for the Borumba Pumped Hydro project, if you were going to do the 2,000 megawatts of power with batteries, you'd be looking at approximately $32 billion initially to set the battery storage up, compared to the $14 billion in the construction scheme with the pumped hydro. And batteries also only last approximately 15 to 20 years compared to the 100 years for the pumped hydro assets. So you'd be replacing those batteries approximately 5 times in that space. So that provides a comparison cost-wise as to why batteries can't do the scale of energy generation as what pumped hydro does. In terms of what you can see on your slide there, so the Green Bank battery scheme is approximately 200 megawatts of power for 2 hours of generation. The Kingston Pumped Hydro project up north is approximately 250 megawatts of power for 8-hour duration. And the Wivenhoe Pumped Hydro scheme, which has been in operation since the 1960s, provides 570 megawatts of power for 8 hours. So you can see the difference in scale for these two projects. So Borumba will provide the 2,000 megawatts of power for 24 hours of duration, and the Pioneer Burdekin is proposed to provide 5,000 megawatts of power for 24 hours. So it's the 24 hours of generation which is the key benefit to stabilising the energy system. So in terms of why pumped hydro and how pumped hydro works, so pumped hydro generates energy from moving water from a lower reservoir that you can see on the right of your screen to an upper reservoir through the top left of your screen. So It utilises the pumping mode during the day when you have excess wind and solar generation in the grid, that exceeds the demand. So with that excess energy that's produced, we pump water from the lower reservoir to the upper reservoir that's shown in the blue arrows. And then of an evening, typically when people come home, the wind and solar generation drops off because the sun goes down and the wind reduces. We have a spike in energy demand. And so this is where the pumped hydro comes in. So we flick a button and then it turns into generation mode, which is the red arrows. So the water drops and then spins the turbines, and then that produces the energy. And then the water flows back out to the lower reservoir. And then we repeat that cycle. So of an evening, potentially you're running the system for a couple of hours, potentially longer, and then you stop the system. So you're not using it for that whole 24 hours. So where the 24 hours comes into it is when you have days when, say, it's raining, it's cloudy, the solar generation has reduced. There's also typically less wind, so that the wind power is reduced. So you need that 24 hours of storage to firm the energy system. So we've got the reliance in the system to produce energy when we need it. So in terms of an overview for the Borumba Pumped Hydro project, so as mentioned, it's located near west of Imbil, at Lake Borumba. So Lake Borumba is an existing dam with a water reservoir. So the project has been located here because it's close to the Southeast Queensland Energy Load Centre and also the Southern Renewable Energy Zone. So that provides good connectivity to the existing transmission network. The land at Lake Borumba has also been owned by the Queensland Government for hydropower electric purposes for approximately 4 decades. And that's because of some of the key characteristics of the site, which I'll get into next. So in this diagram, you can see the Borumba scheme. So in the top left-hand corner, you'll see the existing dam. So if you can see my cursor there, so that's the existing dam at Lake Borumba. So that dam wall was constructed in the 1960s, has already been increased in height once. To meet the dam safety regulation requirements of the dam safety regulator, that dam would need to be upgraded and replaced by 2035, irrespective of this project. So this project assists with making those required safety improvements. So we will build a new dam, which is the proposed dam in the top right-hand corner of your screen. So that dam will be longer and taller than the existing Borumba Dam, and that would increase water levels by approximately 20 metres. So that is the difference that you see in the dark blue, which provides approximately 46 gigalitres of storage, to the light blue, which increases it to approximately 220 gigalitres of storage. So that increase is required to provide reliability to the pumped hydro scheme, to also provide reliability to the existing water allocations, and also to manage the water level fluctuations as we operate the pumped hydro scheme. So for Lake Borumba, it's an ideal location that the government saw about approximately 4 decades ago, because this lower reservoir that exists here is in really close proximity to where we could construct an upper reservoir. So as you can see from the lower middle section at the bottom of your screen there. So the height difference between the lower and the upper reservoir, which is all important to create our energy, is approximately 330 metres. And it's in a really short distance between the two of them. So it's less than 3 kilometres in length for the waterway tunnels. So for a hydro project, it's a really compact hydro scheme, because typically those tunnel lengths are quite a bit longer. So there's Snowy 2.0 over 20 kilometres in length. So this is an ideal site, and why the government's owned it for the last 4 decades. So as we move to the top of the screen, we will be constructing a new upper reservoir. So as you can see from the dark blue in the bottom of your screen there. So the red in that image there shows you the dams that will be constructed. So we'll be constructing 6 saddle dams. So the main one, which you can see with this triangular shape, if you can see my cursor, so that's the main saddle dam. So that dam will be approximately 100 metres in height from toe to top, and that when constructed would be the tallest dam in Queensland. Next to that, we'll build a spillway to control any water releases that need to be done from the upper reservoir. To round out, we're creating a big swimming hole at the top of the ridgeline here. We'll be constructing a main saddle dam, which you can see the long red section at the bottom of your screen in the middle. So that is approximately 1.4 kilometres in length and approximately 40 metres in height. And then there'll be 4 other saddle dams to fill in the ridges to make the sides of the dam. So when this is done, that'll provide approximately 70 gigalitres of storage. So at the moment, the lower reservoir's got 46 gigalitres. So to put it in perspective, we're building 70 gigalitres at the top of the ridgeline. And that 70 gigalitres is the battery that provides the power for this scheme and provides the 2,000 megawatts for 24 hours. So it's because of that volume of water that you can move in that time to spin the turbines and create energy is what gives you the ability to provide such a good amount of energy in such a small amount of time, a small amount of space. So connecting the lower reservoir to the upper reservoir is a series of underground works. So starting at the upper reservoir, you'll see there's some yellowy orange symbols there. So that's the head race tunnels. So we have 2 twin head race tunnels that are approximately 9.5 metres in diameter each. And then they will travel for about 200 metres and then they will drop vertically. So that vertical drop is that approximately 330, 350 metres vertically straight down. And that's what provides that good energy conversion of that water dropping. So that water then drops down to the underground power station, as you can see in the yellow. So within that underground power station, we'll house 6 330 megawatt reversible pumped turbines and also 6 500 kilovolt transformers. After the water passes through the turbines, they will go through into what's called the power waterway tunnels or the tower race. So they're also twin tunnels, approximately 9.5 metres in diameter, and they're approximately 2.5 kilometres in length, and then that'll take the water down to the lower reservoir. Also, as part of the underground works, as shown in the black lines, are the access tunnels. So we'll have twin access tunnels that'll be constructed, and that's how you get both the power from the powerhouse or the power station up to the surface to the transmission lines, as well as having people access the underground works and the power station. So there's 2 twin tunnels, approximately 8.5 by 8.5 metres in dimension. And as part of the initial phase of the project, which is called the exploratory works, we will construct one of those access tunnels to gather the valuable geotechnical information that we need to inform the design for the scheme. So this is another way to show the scheme configuration, just as a bit of visualization, so you can see the difference in elevation from the upper to the lower reservoirs and all of the infrastructure that I've just talked you through. So I find this is a really good diagram just to see how it all fits together. So you can see at the top of your screen the upper reservoir, and then how the tunnels come horizontally almost for about that sort of 200 metres, and then that vertical drop. And then it gets into the powerhouse area with our turbines and our transformers. And then, off to the left of your screen, and that's how it goes to the lower reservoir. And coming out towards you in the screen are the access tunnels. So that gives some really good perspective for what the scheme actually looks like. So in terms of the timeline for the Borumba project, so we've gone through some investigation stage, which took place from January 2022 through to December 2022. And then we produced what's called a detailed analytical report for government on the 31st of March 2023 this year. The next stage that we're currently in now is shown in that black box, which is the exploratory works. So the exploratory works will run for approximately 2 years, and they're major works relative to other infrastructure projects. So they're approximately 400 million in expenditure across those 2 years. And they're very critical in terms of gathering the environmental information that we need to inform our engineering impact statement under the Environmental Protection, Biodiversity and Conservation Act, as well as providing the critical geotechnical and design information that we need to inform the design development for the scheme. So that's why it runs for approximately 2 years to gather all this important information. Come late 2025, we anticipate getting our EIS approvals, and then we're targeting first power by 2030. So in terms of some work coming to market for the Borumba project and the exploratory works period, which is over this next 2 years, we have typically 8 packages that have currently come to market or on the stages of coming to market. So these include the underground works, which is the exploratory drilling. So that includes the tunnel that I talked about, one of the access tunnels. And then we've got geotechnical drilling in the box in the bottom left-hand corner. And that's about the surface geotechnical drilling. So to inform our design, we need to do a lot of investigations from the surface to work out what's the ground conditions underneath and how they inform how our design is developed moving forward. Then in the lighter blue boxes, we've got the owner-provided technical assurance works for the drilling. So that's the access tunnel drilling. So that's some key partners that we need to help us provide the supervision and technical support to inform those works and manage those works. We've also got the owner-provided technical assurance for the geotechnical surface investigations, and that will include lab testing and analysis, as well as providing that on-site supervision and technical support for us. And then we move into the civil construction works. So they will include the access roads, access tracks, the installation of temporary bridges, the installation of the access grids and some access tracks, as well as construction temporary water. And the accommodation is going to be provided in some temporary accommodation camps within the Queensland Hydro property. And they're currently out to market, which I'll provide a little bit more detail on the dates for all of these. And then we've also got the temporary bridge supply, as well as the survey control works. So just to provide a little bit of a schematic around the timing of all these 8 packages. So this shows you when the tender periods have started and when they're due to be awarded. So the aqua colour is if we're doing a 2-stage process. So the expression of interest would occur in the first stage, and then the second phase would be the tender period. And then the diamonds that you can see, that's when we anticipate the contract award. So in terms of providing some more specific dates, because that diagram might be hard to come up and look timing wise. So for the temporary bridges, we went out to market with an open tender September this year, and we're looking to award that in December this year. For the owner's technical assurance for the geotechnical assistance, that will come out, or that's gone out October this year, and we'll be looking to award that December this year. For the exploratory drilling, we're doing a 2-stage process. With the EOIs went out last month in October, and then we're looking to shortlist that those expressions of interest down in February next year in 2024, and then looking to award in August 2024. For the temporary water will come out this month for that, and look to award that in January next year. The geotechnical drilling program will look to go out November this month, and then award April next year. And then establishment of the survey controls will go out to tender January next year, with an award anticipated April. And then for the owner's technical assurance for the drilling, that'll come out February for the tender, and then looking to award that April. For the temporary workers accommodation camps, so we went out to open tender September this year, and those have closed, and we're under the assessment period now, so we're looking to award that in February next year. And for the civil construction works, we knew this was going to be of high interest, particularly to local providers. So we've gone out with a 2-stage process. So the expression of interest went out in September. That expression of interest has closed, and so we're in the process of shortlisting. So we're looking to do a request for price this month, and then to award that in April 2024. So in terms of doing business with Queensland Hydro, we provide a little bit of information about to make sure that you're business ready to do business with us. So that can either be direct with Queensland Hydro, as you can see on the right of your screen. It could be indirectly with our delivery partners. So there'll be a number of delivery partners. So they're the main contractors for some of those 8 packages, as well as into the main works as well. Or it could be the auxiliary services. So they might be, for an example, the workers' accommodation for the provision of the food and the cleaning services and the administration and so forth. So it's important that you make sure that you're, that you know that Queensland Hydro is going to provide full, fair and reasonable opportunity for Australian entities, and particularly the local and Indigenous businesses and social enterprises. So we're all about supporting the local businesses and making sure that all of you have the best foot forward to try to get as much work as possible through our projects. So we use our procurement power to create and support quality and secure local jobs for Queenslanders, and also to buy from local businesses and suppliers. So there will be requirements within all of our contracts for people to buy local, as well as for local employment as well. So there's plenty of opportunities, whether it's direct with Queensland Hydro or indirectly, where there's going to be opportunities for local providers as well as local people. And we're also going to ensure that the regional communities and workers have the ability to be part of this energy transformation, and also to benefit from the opportunities that it brings. So you don't get too many projects of this scale. So the Borumba is the largest project in Queensland's history at 14.2 billion. So the responsibility on us is not lost in the way that we need to make sure that we proactively and mindfully plan this project and undertake this project to make sure that we can generate as much benefit as possible for Queenslanders. So in terms of your businesses, our tips are to be visible. So prepare a business capability statement that communicates who you are and what your business can offer to prospective buyers. So this will help not only for you doing business directly with Queensland Hydro, but also indirectly with our contracting partners. So please register your company's capability on the ICN gateway, and we'll provide some details directly for the Borumba one later in this presentation. All of our tenders will come out on QTender. So we're a government-owned entity, so all of the tenders go through QTender. So you need to be registered on QTender and make sure that you register what you're interested in that. And also Queensland Hydro's website will provide a lot of information on our projects and the timing of tenders coming out, and we'll have links to both the ICN as well as the Q tenders. So we encourage you to establish a website and social media presence, and LinkedIn in particular, because hydro projects are global projects. So we will have local Queensland companies, but we'll also have international companies that are looking to establish offices and facilities within Queensland on the back of these projects. So we do encourage you to make sure that you are visible, particularly on LinkedIn, because there's lots of activity already on LinkedIn. We also want you to attend industry events such as this one today, and also any briefings that we've got. So we'll be rolling out ongoing briefings for the project to make sure that industry is well informed. Make yourself known to our contracting partners and subcontractors bidding for our work. So we will have information about who are the successful tenderers provided on Q tenders, as well as on our website as well. So you'll be able to see who those partners are. Reach out to your existing clients, and also make connections with businesses that have supply contracts with Queensland Hydro. And, of course, your local Chamber of Commerce and industry associations are fantastic sources to expand your contact base. So part of tendering with Queensland Hydro is about being compliant as well. So there's some typical selection criteria that we'll require in our tenders. So it's important that you're aware of these details to make sure that you can provide compliant tenders. So there's the capability to deliver the scope of works to the provided high quality outcomes on time and on budget. There's the resource and financial capacity to deliver the works, and also your previous experience in delivering similar works. So a lot of these will come up in the questions that you need to, or the criteria you need to respond to as part of the tenders. You'll also need to have workplace health and safety systems and standards in place for your businesses, and have a commitment to skill development and training via apprentices and trainees. So the benefit of the Borumba project is that because of the timeframes, so it's approximately a decade, we have the really strong ability to provide career path for people. So that training and development is a key part to make sure that we can provide as much benefit as possible to our local communities and to Queenslanders. So best practice industry relations will be requirements within our contracts as well. And the accreditation, so there's licenses and insurances, as well as some management systems that will be specific to the scope of works for each tender. So you know your business is best, so just make sure that your licenses and insurances are up to date, and there might be some different levels that you need to investigate as well as to enable you to do business, or maybe even partner and provide make joint ventures with other businesses as well to make sure that you can get the levels that you need to be compliant. And then importantly, there's also the environmental, social and corporate governance outcomes, including demonstrated spread of local economic and community benefits. And also, I guess it's the price as well. So that's not the number one driver, but there is always a need to be competitive with price and to provide a high quality product or service. So we encourage you to be prepared. So here's some 7 steps about a typical procurement process. So step 1 is typically the registration or the expression of interest phase. So there's some acronyms for that. So the ROI or the EOI, and that's about prospective suppliers, encouraged to register your interest, as we've talked about before, on the ICN networks and also on Q tenders. So step 2 is typically an evaluation of these expressions of interest or these registrations of interest. So this is the responses to the work packages, as we've talked about as an example. So the civil works, we went out for an EOI first, and then we'll shortlist those candidates down. So this is an example of that. Step 3 is the shortlisting. So that'll be the list of the potential suitable contractors that it'll drop down to. And then step 4 is the pre-qualifications. So businesses selected, in some instances, you need to have pre-qualifications depending on the scope of works for the tender. And that's about your suitability to do the work. Step 5 is typically the request for quote or the proposal or tender. So the shortlisted businesses get the opportunity to provide a quote or proposal for the tender and provide that in their submission. And then step 6 is the evaluation. And then step 7, the award. So the next steps that I'd encourage you to do is register your interest at the Borumba Pumped Hydro ICN website, and also jump onto Q tenders and register your interest is there. And if you want any more information, please go to the Queensland Hydro website. Thank you.